For our video, we have decided to do spontaneous versus non-spontaneous processes. A common question that we have come across while comparing these two processes is what makes certain changes spontaneous while others are non-spontaneous. In this video, we will use different demonstrations of real-world examples to explain each concept and the meaning behind it. Spontaneous processes are changes that continue to occur once they have started. Energy is a main factor in determining which term applies to which concept. Spontaneous reactions occur when energy is released and the object moves to a more thermodynamical, stable energy state without the need for a continual source of outside energy. A non-spontaneous process occurs when there is a requirement of continual outside energy for the process to occur. First, we will demonstrate a series of spontaneous processes. Here we have Samantha sitting up at the top of a hill on a bicycle. When she gives the bike a push without pedaling, it spontaneously rolls down the hill without the continual input of energy. It will release its stored potential energy as it does so, making it a spontaneous process. Here we have a bucket of ice cubes and a bucket of lukewarm water. We are going to demonstrate a spontaneous reaction. We are going to put ice cubes in the lukewarm water, which is at room temperature, and allow them to melt. We are going to come back to this towards the end of our project, and then I will explain to you why this is a spontaneous reaction. Here is another example of a spontaneous process. An everyday example is burning a log of wood, or in this case, burning a stick of wood, where the burning reaction is clearly an example of a downhill process and thus defined spontaneous. But without a flame to supply heat to overcome the activation barrier, the reaction will not occur. Another example can be seen when adding Mentos to Diet Coke. A spontaneous process will occur even though there is a slight contributing factor in order to start the reaction. It is still considered spontaneous due to the fact of the releasing of energy with no continual input of outside force. So here we have three nails in front of us. The oxidation process from iron into iron oxide is spontaneous. Here is another example of a spontaneous process. In front of me, we have a bucket of water and food coloring, as you can see so there. We are going to take the food coloring and place it into one corner of the bucket of water. The dispersion of the color from one side to the other makes this process spontaneous due to the expansion, as you can see so here. Now we are going to demonstrate a non-spontaneous process. Here we have Samantha on a bike and a hill in front of us. In order to get up the hill, Samantha will have to continuously pedal, putting external force and input into the object. Because this change requires the continual input of energy, this is a non-spontaneous process. Another example of a non-spontaneous process is the winding up of toy cars. They will not run by themselves unless something keeps them going. Samantha will wind them up and let them go. As you can see, those two cars go, but those stay still. They will only move forward if the coil is wound, making this a non-spontaneous process. Now we will make our way back to the ice cubes we left in the lukewarm water, as we did our other experiments. As you can tell, this is a spontaneous process because the ice cubes melted on their own without the continual input of outside energy.